Okay, so in this last section, 4.7, we're going to be looking at scatter plots and lines of fit. So we're bringing in a little bit of a data lesson with our linear functions lesson. So we're going to start by talking about scatter plots, which is just a method of visualizing two variable data is called a scatter plot. So filling in that blank. A scatter plot is a graph of points with one variable plotted along each axis and can show trends in the data. Now, this first example hopefully will be very easy for us. We're just going to be interpreting this scatter plot. So we're given a scatter plot that shows the amount of grams, which is our X value of sugar, and the number of calories, which is our Y value in a smoothie. So A just says how many calories are in the smoothie that contains 56 grams of sugar. So we know that our grams of sugar are our x-axis. So what you would do is find the point on the scatter plot that has an x value of 46 and find the y value. So it's kind of like evaluating a function. When the x value is 56, what was the y value? So 56 would be right in between 54 and 58, and if you find that point, you find that the number of calories would be 270 calories. All right, so it's just making sure, do you know how to read kind of a graph? B is a little bit the opposite. How many grams of sugar are in the smoothie that contains 320 calories? So now the number of calories is along the y-axis, so we've given you calories, 320. You're going to find that point that has that as a y value and find its x. So 320 is going to be up here. That's this point. What's this point's x value? 70. So 70 grams of sugar. And then C asks us about this trend that we see in our scatter plot. What trends or what tends to happen to the number of calories as the number of grams of sugar increases? So what do we see? What kind of trend do we see with this scatter plot as we're increasing the amount of sugar in our smoothie? What's happening to the amount of calories? It increases. Very good. It also increases. So that's pretty easy. We can look at a scatter plot, we can find a point, and we can interpret what that point means in terms of the data that we're talking about, okay? The next thing we're going to look at with scatter plots is correlation. So a correlation, filling in that blank, is a relationship between data sets. We can use a scatter plot to describe the correlation between the data. So if our data is increasing as we look at it from left to right, then we're going to say that that has a positive correlation. If we look at our scatter plot and that trend seems to be decreasing as we look at it from left to right, then that's going to be negative. Or we could look at scatter plots and we would see no kind of trend. So if you don't see any sort of trend in the data, then there would just be no correlation between whatever those two variables are that they're measuring. Like maybe it's like number of siblings and shoe size or something like that. Like those two things wouldn't have anything to do with each other, right? So we wouldn't see any type of relationship or trend. Okay, so now that we've talked about those three types of correlation, let's see if you can identify it. So I've given you two scatter plots here. Number two, we've got the age of the car and the value of the car. So what do you notice? What kind of trend do you see with that scatter plot? It's decreasing, so this would be a negative correlation. And then number three, we're looking at the temperature and the number of people at a concert. So how do you see, when you look at that graph from left to right, what kind of trend do you see with that data? What do we think? Positive, very good. It's increasing. It might not be as drastic as our negative, but you still do, if you were to kind of draw that trend line, that would be increasing. So this is a positive correlation. All right. So that's the easy part. Number two is, or the second part's not any harder either. But now that we've talked about what a scatter plot is, we're going to pull it into our linear functions. What does this have to do with linear functions, okay? So when data shows a positive or negative linear correlation, we can model the trend in the data using a line of fit. And here's where our linear functions come in. So a line of fit, or maybe you've even heard it called like line of best fit. If you've seen this before, I can't remember if it's like a pre-algebra thing or not. But a line of fit is a line drawn on a scatter plot that is close to most of the data points. So again, you draw that line as close as you can to your scatter plots, making sure there's about as many points like above the line as there is below. So what we're going to practice here is we're going to take some data. We're going to create a scatter plot. And we're going to find the equation of a line of fit, of the trend line of the data, okay? So our example here, we're going to use the data to make a scatter plot. And we've got a part A and a part B. So it says, A says, write the equation that models the data and interpret the slope and y-intercept. And then part B is to estimate the arm span of a person who is 67 inches tall. So we'll do part A and part B. We're going to start with, I've given you your steps here. Step number one, the first thing we're going to do is actually make the scatter plot of this data. So you can see the two variables that we're looking at is going to be the height of a person and then their arm span. So how tall they are is going to go along their x-axis, and then their arm span is the y-axis. So we're going to plot these 1, 2, 3, 4, 5, 6, 7, 8, 9 points. And then we will do part A. So let's see, 63, 62. So both axes are numbered by 2s. So if I have 63, that's going to be right in between 62 and 64. But then I can go up and plot that at 62. And then 70, 67. So again, 70 is going to be right on the line, but 67 is going to be in between. So you're just kind of estimating where that goes. Then we've got a point on 60, 60. So 60 is right here. So over to 60 and then up to 60 and plot a point. Then we have 62, 61. So again, 62 and 61 is going to be right in between the 60 and 62 on the y-axis. And then 64, 63. Right there. Then we've got 65, 65. So right in the middle, and then also right in the middle, so right about here. We're taking the points from this table and graphing them. So we should be able to do that. You've got X, Y points. This is your X, this is your Y. And we are plotting those points. All right, so I just did 65, 65. So now I'm going to do 72, 70. 72 up to 70. Then 59, 59. So again, kind of right in the middle. And 61, 60 is that last point. So in the middle and then right here. All right, so we've got those 9 points on our scatter plot. Now we have constructed that. Give everybody another 30 seconds or so to finish getting those points on their scatter plot. And then step number 2, first we're going to decide whether this data can be modeled by a line, meaning do we see either a positive or negative linear correlation? Yes, we do, right? We've got that increasing trend there. So what we're going to do then in step 3, now we're going to get into part A where we're writing the equation that models the data. So we are going to draw a line that appears to fit the data closely. There should be about as many points above your line as there is below it. So when I go to draw my trend line, for example, I don't want to draw it like this. All the points are below it. It doesn't even go through any points. Like that would be a bad trend line. So you want your trend line to go through the middle of the data, maybe something like that. I've got this point kind of above it, this one kind of above it. And that's the best I've got. My trend line maybe not as straight as yours, but. Okay, so what we're going to do now that we've drawn a line, we're going to write the equation for that line. So you're going to write the equation of your line using 2 points. Now, these 2 points don't actually have to be data points. They have to be points on your trend line. You can't write the equation of a trend line if you choose points that are off the line. So if you look at my trend line, which yours might be a little different, but my trend line really doesn't go through any of them. Maybe it goes through this data point, but it's really not hitting directly any of these other points. So I might choose, the way I drew my trend line, to use this coordinate point, which would be 62, 62. And then maybe I would use this point where it goes directly through those coordinates, which would be the point 70, 68. So you'll notice I'm choosing 2 points that didn't actually come from the data, but they're on my trend line because I'm writing the equation of the line. And then once you've picked those 2 points that you're going to use, now we're doing everything we did in 4.5, 4.6. We're going to find the slope of the 2 lines that we picked. So I would use that slope formula of y2 minus y1 over x2 minus x1. So I would do 68 minus 62, and then 70 minus 62. So my slope, 68 minus 62, would be 4. 70 minus 62 would be 8, and then that 4 over 8 would be 1/2. What did I do?
You did 4.
Oh, sorry. Okay. So I would get 6 over 8, which would reduce down to 3 over 4. Very good, thank you, sorry. Okay, so now I have my slope. And now that I have my slope and I've got some points, I can easily use that point slope formula and write my equation in y equals mx plus b. So I will use, I don't know, I'll use the 70, 68 point. If you want to use the 62, 62, you can. So this would be y minus 68 is equal to 3/4 times x minus the 70. So again, I'm just using that slope that I just found and one of my points from my line, plugging them into that point slope form. So I would go ahead and distribute this. So I get y minus 68 is equal to 3/4 x. And then this might not come out beautifully, but we can leave it as a decimal if you want, since it's our y-intercept. So 3/4 times negative 70 is negative 52.5, especially because we're talking about height and stuff. So we can have, you can be 52.5 feet or whatever. Huh? And a half? Yeah. A foot is 12 inches. So if you were like 4'6", you're 4.5 feet.
52 feet tall?
Well, I think this is inches.
Oh.
52.5 inches. Did I say feet?
Yeah.
Oh, okay. Inches. So we're adding 68. So when we add that 68 to our negative 52.5, we get y equals 3/4 x plus 15.5. So now we've been able to construct our scatter plot, draw our trend line, write an equation for our trend line, y equals 3/4 x plus 15.5. And then now we're going to practice using our trend line or our equation, because then B says estimate the arm span of a person who is 67 inches tall. So remember, the height of a person is our x value. So they are giving us a value for x, which is 67. So now we're going to use our function notation stuff because we have an equation and they're giving us a value for x. So what do you think we should do with that to find its arm span? Oh, I know why you guys are smiling now. But what do we do with 6, 7? We're distracted. We have the equation for this trend line. Put it in for x. They're giving us a value for x. X is the height. And we have an equation where then we can find the arm span, which is the y. So we're going to use our function notation, plug it in. What's the output value when the input value is 67? Hee hee hee. So this would be y equals 3/4 times the 67, which might not be beautiful, but so when we multiply that, and then add, so this gets us 50.25, and then we're going to add the 15.5. We could say the height of this person, or the arm span, 65.75 inches. So if you are asked to write the equation of a trend line, all you are doing is writing the equation of a line, the same thing I could have asked you to do in 4.5. We just now are applying it to a scatter plot. All right? Good job. So we got the last one, and this one's going to be much faster because the scatter plot is already there for us. The trend line is already there for us. A group of hikers are descending, and the elevation of several of the hikers after a certain number of minutes is shown in the scatter plot below. They determine the equation for their line of fit to be y equals negative 125x plus 2,500, where y represents the elevation in feet and x represents the number of minutes spent hiking. Based on their model, what is their projected elevation after 12 hours of hiking? Here's their model. If they want us to find 12 hours of hiking, what variable have they given us? X. But this also says 12 hours, and X is in minutes. So we got to convert how many minutes are in an hour. So 720 minutes. I'm trying to decide at the current moment if we are supposed to do that or if it's going to be a typo on my 12, if it should have been minutes instead of hours. We'll find out very quickly when we plug it in if it makes any sense at all. All right, so if we use their function, we're plugging this in for x. But again, I'm worried I might have made a typo since we've got minutes here, but we'll see. Did I do a typo? Wow, it's such a typo. Okay, JK, erase. Yikes. This is definitely something, though, that they would do on the EOC, so be on the lookout, people. Make you have to convert something before you plug it in. But instead, this is just a misgrading mistake. Okay. So our x is just going to be 12. Y equals negative 125 times 12 plus where they started at that 2,500. Is that going to make more sense?
It gives you, when you multiply, it's just negative 15.
So negative 1,500 plus the 2,500. When we add those, we get that they would be at a elevation of 1,000 feet, which definitely does make more sense because 1,000 feet would be right here, and this is where we're at 10 hours. So yeah, it makes a lot more sense based on what the data is doing. All right, so that concludes scatter plots.